Hello, this is Darren Pulsipher, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, advances in big memory architectures with special guest Charles Fan, CEO of MemVerge. Charles, welcome to the show.
Hi, Darren. Glad to be here.
I'm glad to have you back. It's been, 6 months, 7 months since you've been on the show?
Yeah, something like that.
Yeah, last time we talked about use cases. That was great. We even did a spot together for supercomputing.
That's right.
Yeah, with it was you and I, and Penguin was on. We showed how fat nodes worked in high performance clusters. But today, you got some exciting things for me today to talk about how MemVerge is really changing the use of data and memory. What do you got new for me today? What's that new hot topic in the memory realm?
Well, the big keyword is three letters, CXL. So that's getting a lot of buzz, and we have a very strong ecosystem being developed from the whole side, the CPUs, Intel, AMD, others who are supporting CXL in their next gen platforms, Sapphire Rapids, Genoa, and so on. And then we have the people on the memory side, including Intel Optane, shared that their fourth generation will be on CXL. We have a new product coming out of Samsung, Micron, SK Hynix, all the leaders in the memory space as well. And we have new interconnect that are being developed that can potentially connect memory with the fabric. So it will be a fabric-enabled memory that can be shared across multiple servers. So I think that's a very exciting development.
Now, what does CXL stand for? I've heard the letters fly around. Do you remember what it stands for?
It stands for Compute Express Link. So
right, Compute Express Link. So this is a game changer, right?
It is a game changer, and this essentially is a new memory protocol that runs on top of standard PCIe, in particular PCIe Gen 5 and later. And so it runs on the most standard interconnect, and now you can run memory on top of it. Before PCIe, you can put a lot of stuff. You can have a GPU there, you can have various processors there, you can have your network card, you can have your storage systems, but you cannot have your memory there. Now, CXL allows you to put memory on PCIe, and therefore, not only it can be inside the box on PCIe, but in the future, with PCIe switching, you can have the memory to be on the fabric and become composable and shareable across.
Okay, so those of you that have heard about MemVerge before, this is perfect for you guys.
Yes, we've been waiting for this for the last 5 years.
Yeah, because you guys have a software-defined memory controller, which in order to make this all really work with lots of different applications and use cases, you'll need something like that, and you guys already have it.
Right, and it opened a complete different new world for the software that we have been developing. I often think about this with analogy, analogy to the storage world, which I had been working in for the last 20 years before I started MemVerge. And so the storage industry started around end of 80s, beginning of 1990s, when fiber channel came along. That allow you to changing the model from a direct attached storage that's inside a server or directly one-on-one attached to a server into a fabric-based storage architecture or storage area network, SAN, as it was called. So once it's externalized, it's disaggregated from compute, that makes it independent, make it scalable, and make it more manageable. And you can protect it better, you can have a higher utilization, and you can have better agility in terms of assigning these resources to the various different computing hosts. So really, you are turning physical resources that's hardwired to a particular computing system into a logical resource that can be dynamically allocated to various computing units.
Well,
Yeah.
Yeah. So do you see maybe a box just full of petabytes of PMEM, and that's all it's in that box, and thousands of computers attached to it? I mean,
Yes.
almost like a SAN,
Yes. Something like
but
that. So it's like a
network. Wow.
so it's like a memory area network, rather than a storage area network.
All right,
And
we just coined that today. Memory area
man,
network. Man,
we are
there you go.
creating man.
Charles Fan is the man. He created man. This is pretty. This is a game. This is huge, because I can now start imagining. I may even be able to go directly from network cards directly into memory with CXL and bypass the CPU completely.
Yeah. Yes. So immediately it's not network card. It will be through the CXL capability. So CXL is the new network for
Right. Yeah.
for this. And by the way, there is a very strong CXL consortium being assembled, with Intel being one of the driving members, and there are other industry leaders, almost all participating in this consortium, and they have been defining the standard. Now 1.1 is the first version of the standard that's going to materialize in the new platforms, including Sapphire Rapids, which is going to support 1.1. And 2.0 has already been defined. That has additional capabilities, including this sort of externalization and switching of CXL. And then 3.0 is being actively defined right now, and that's going to try to standardize some of the way how this can be shared and provisioned, and all the control path protocols associated with that. So there is standard body work that's happening in parallel. At the same time, the industry we are looking at the first CXL product coming out by the end of this year.
That's awesome. So it's interesting. I'm glad you brought that up, because it's not just a faster connection.
Mm-hmm.
There's protocols here, because dealing with memory is very different than dealing with storage.
That's right.
Right.
So,
because there needs to be more communication and acknowledgments, right, and things like that.
Right. And for one thing, it's 1,000 times faster in terms of latency.
Yeah, there you go.
Right. So storage, you're talking about microseconds of latency, and that's a very fast network. Even RDMA have a few microseconds of latency, and with CXL, you're talking about 100, 200 nanosecond of latency. So that's latency on the memory scale. So it's much faster. So it will be different. So it's only analogy, not exact, but some of the same concept applies. So this is where you increase the utilization. This is where you increase the manageability, and this is where you can allow more agility. And this is where you can provide higher availability and productivity in terms of the use of memory.
Well, and this could change the way that we even think about the way we provision resources for an application. I can now provision memory dynamically, right?
Right. So you can provision memory as needed, and it doesn't all have to fit into the server box. So to give you a more concrete answer to your earlier comment, so this is not gonna, at least in the immediate future, connect to thousands of nodes. So we think this is more of a rack scale architecture. It will be a rack top or rack bottom a switch or a memory box. That's just a box of memory, and that's box of CXL memory. This could including DRAM, could including Optane, could including other type of memory, all within that box. And that box is connected to all the servers on the rack through this CXL. PCIe Gen 5 link. And then each of the servers in that rack will have some memory inside. And then if they need more memory than what's inside, then they go provision out of this memory box to really to add to the local memory they have. So this is one model how this could be used.
Yeah, that opens up. I was just talking to a customer that had a really large database.
Right.
It was something like 50, 60 terabytes.
Right.
And they wanted to run all these queries on it, and it's just taken forever because it couldn't bring everything into memory at once, right?
Yeah.
And we've written very complex software to handle that. Not everything can fit into memory.
Right.
With this,
You
everything can fit into memory.
Right. Theoretically, you always have enough memory for whatever you need actively. So for all your active needs, you'll never be out of memory.
And also with your guys' technology, I can also snapshot it too, which means it's persistent.
It's protected, right?
It's protected and persistent.
Right. And this is especially more important when your memory becomes bigger. When you put everything in memory, then you need to protect it because if you lose it, you lose more. It's harder to reconstruct.
It was a major paradigm shift for a lot of programmers.
Yeah. Yeah.
Right. And we've talked about this before. How is that going for you guys? Are you finding people wanting to adopt this more? Hey, I can persist my memory without having to write a middle layer, right? A database or an ORM or whatever it is that I'm converting.
So that's a great question. So I think for the CXL to take off, it needs a few things. First, on the hardware side, it needs the all the hardware leaders, manufacturers, vendors to be on board and to embrace the same standards. And that just happened over the last year. So I think there are some competing protocols that has been merged or stopped. So there is a single standard that everyone is supporting. Second, like you said, you need the applications to be able to use it. And the best way of achieving that is you can do it the way that there's no change needed from the application. And that's exactly what happened actually when storage area network came about. From a database point of view, you don't actually
care where it is.
You don't have to rewrite, whether you're using a hard drive in your computer or you're using a SAN LUN, it's the same thing for the application. As far as the application is concerned. And I think we're going to see the same thing here with CXL, that between what standards provide and what operating system supports, and with software such as ours that can do the auto tiering between DDR memory and CXL memory. If you listen to our first show, that's our first feature is to be able to auto tier between different type of memory. Now we just applied that to DDR and CXL and make that transparent to the applications, and they can.
They don't care.
You don't care where it goes, right?
So you guys with MemVerge, you guys can really offer that abstraction layer,
right?
Almost to the point that we saw what VMware did with VMs, right?
Right. It's a memory virtualization, essentially, or software-defined memory that we are handling the actual placement onto the physical memory. And all the application care about is going to memory and doesn't even need to know.
Don't even care. And like we've mentioned before, you guys offer more than just the tiering. Because you created a full software-defined memory controller, which gives you a lot more like management of memory. And one of the most beautiful things that I thought was snapshots.
That's correct. So the first thing we want to do is make the memory transparent, the big memory transparent to the application so they can enjoy the higher capacity, that they'll never run out of memory again. Now, once you have that, the need for data services, or at least the data protection, goes up because the memory is bigger.
Yeah, it's huge. Yeah.
You need to protect it. And when you look at data protection, a fundamental service that people have figured out how to protect data is by taking a point-in-time snapshot. So this is, you get a consistent state of your storage or of your memory system, wherever you store your data, and being able to remember it. And you can recover to that point in time at any time. And this is what we developed, is an in-memory snapshot service that can capture per application its entire state in memory. And we'll make sure that state is immutable and it can be recovered anytime, anywhere. And we are very excited about that snapshot service. And there are many use cases with that.
Oh yeah,
And
my
I think,
brain's just going wild on that one. Like ransomware
right,
remediation, right?
right,
If I have a snapshot of my systems,
right. You
I
can
can
just
go back to a well-known state like
that's right,
that,
right,
right? I can have
right.
minimal downtime there. Oh man, this is
It's like an autosave of your memory.
autosave.
Like
I don't know. Sometimes that autosave messes up. But
yeah.
no, that's very powerful. So like, let's switch CXL. I mean, that's future stuff, so that's not here today. That's next year stuff. But you guys are right on the front end of that. So when
Yeah.
CXL comes out, you guys will be able to provide the services that you already do.
That's right.
Let's talk about some use cases today.
Yeah.
Some new use cases that you guys have found. We already talked about some really cool ones where you decrease cycle time on genomics research. Go back and listen to that old podcast. Incredible what you guys did there. How can you use that same techniques in different areas? So give me some examples.
Yeah, yeah. So, talking about genomics, we just won a couple of good awards on
Oh yeah,
IMIT.
congratulations on that.
Right. So it actually just took place last week. It was great. We won both the Best of Show as well as People's Choice Award. And they say this is the first time the same company won both awards in the same show. So,
Congratulations, Charles. That's awesome. I knew you guys had
and,
it. I'm a big fan of your guys. You guys already know that.
yes, and in fact, this is exactly what I'm going to go into the use case, and it's related to the snapshot, the cool snapshot feature that I just mentioned. And I think what the people really liked over there, both the judges as well as all the bio researchers and all that, is our snapshot feature where we can quickly and easily capture a running pipeline and allow you to roll back and recover anytime you want. And then we introduced an additional use case based on snapshot, for genomics use case as well as other use cases that really became the one more thing that got people excited. And that's how we use it on the cloud. So a lot of these genomics people in particular, and in general, almost everyone, are looking to how to move to the cloud, how to move to their current analytics pipeline, all these data intensive workload, how do they move them to the cloud? And for some, it's been difficult because for a number of reasons. And one of the top reasons is it turns out cloud is not cheap. It's
not. It is.
It's actually more expensive, and compared to you running certain things on-prem, and if you want to build the exact same setup in the cloud, and over a 3-year period, it's like 3 times the cost of what you would have spent to buy that stuff on-prem. So that has been a roadblock for some of these guys to go into cloud. But at the same time, cloud offers a lot of goodness. It's really easy to use for the researchers. They love to just be able to go there. So now the use case we discovered is that we can allow them to go to the cloud, but at the cost lower than on-prem.
How did you do that? All right, this is voodoo magic now, Charles. Come on.
So now the audience might know that there's not so much of a secret that there is another class of service all of these cloud service provide: AWS, Azure, Google.
Right, spot instances, right? Everyone.
Right. Spot instances, and these are cheaper instances, as much as 70, 80, 90% off of your on-demand price. However, there's a catch where they can take it back anytime they feel like, and they give you like 30 seconds to 2 minutes of notice. Not really enough time for you to do a lot of things to deal with that.
Right, especially if you're crunching genomics research, right?
Right, especially when crunching, especially if you have a lot of data in the memory, it's not even enough time to copy
to
them,
dump it. Yeah.
Dump it into storage. So therefore, the cloud service providers are not recommending you to use those for your stateful long-running workload. And you should use it only for your stateless or built-in fault-tolerant apps that doesn't care about things being taken away. Then you can save costs. But for the genomics, for the big data apps, for the various stateful apps, it doesn't apply. So you cannot use it until now, until MemVerge. So now with our snapshot capability, that we have built in a capability we call fault-tolerant service for the cloud, that we can take periodic snapshot of your running workload in any instance, including spot instance. So if you want to use it in spot instance, we can take a snapshot every 20 minutes or every other interval that you define. And every time we just capture the delta. And after we take the snapshot, in the background, we would move it to a storage service, whether it's S3 or whether it's just your data volume. And in the case that if this instance is taken away, then you have a snapshot that you can recover the instance from and then continue running from that point on. So essentially, we give you a insurance that allow you to use the low cost service with the protection, even if it goes away, that you can still continue.
That you can, so here's an interesting question. Can you get an event? Because I know in a spot instance, they'll let you know this instance is going away in 30 seconds.
Right.
Can you capture that event and do the snapshot?
So we can. And that's part of our process. So the notice, to be exact, is 2 minutes for AWS, 1 minute for Azure, 30 seconds for Google. And we would capture that signal. And the first thing we'll do is try to do a new snapshot. And however, just doing a snapshot is not enough because our snapshot is in memory, and that just takes a split second. So that right away. But then we need to move that thing to a storage service. And if that's enough time for us to move it, then you have the latest. You don't lose anything. And because we have done the snapshot before, so all we need to move is the delta. Is the delta, which is like 5%, 10%, or 20%, depending on your workload, how much of the memory has changed. So it makes it more likely for you to be able to complete that persistence move within that 30 seconds to 2 minute time window. But it's not guaranteed. So it's possible that we won't be able to finish this delta move during that window. But no, it doesn't matter because in that case, we just go to the last good one. So go back to 20 minutes ago, and then we recover from that point. So you lose up to 20 minutes of work, but you don't lose 2 weeks of work.
Right, and you can fine tune that 20 minutes to whatever value.
Right, you want, right? You can define the intervals, how frequently you want to take the snapshot.
So that's pretty cool because I can always go back to a known good state.
Right. You can always go back to a known good state that give you the smallest RPO.
All right. My brain's going crazy, right? Because I'm now thinking if I can take a snapshot of a running instance, right? Because I'm taking the snapshot of not just an application. I could take the snapshot of a whole container or whatever, right? Whole instance, saved off. Does that mean I can reinstitute it anywhere?
Yeah, you can reinstitute it anywhere. That's okay. So
like even back on prem.
Yes. So you are doing the advertisement for us right now. So with this same technology, not only can you provide the fault tolerance or high availability, but you can also provide the mobility service. By capturing the application and move it to another instance. And this instance can be within the same cloud. It could be on-prem. It could be in another cloud. So this essentially allows you to dynamically move a long-running stateful workload while it's running. So like by capturing a state and moving it to other places.
So, wow. So this would have helped a lot. AWS and Azure and Google have all had some major outages this last year, right? Which, they're growing. I understand there's a lot going on, but this could give me some resiliency in my operations as well.
Right, right.
Saying,
Exactly.
hey, one region went down on AWS, I can move it to a different region.
Yeah.
I'm back up. No
Yes,
problem.
yes, exactly. And
Or I move it between clouds or on-prem. This gives me a lot of mobility.
yeah, yes, and I think you also touched on another key word which has been important for us in the last few months, which is containers. And so we have done some work to making sure we can capture the snapshot of a containerized application, including the containers. And then we can integrate with Kubernetes and allow that to be orchestrated from Kubernetes. So,
okay. Now that is really fascinating, because I know because we talked about this before. I can take a snapshot of a container now. Right. And I can multiply it several times.
Right.
And even change configurations and then run different. So I can get to a point on a simulation, like in genomics, and say, I want to try 5 or 6 different things out from this snapshot and go in different directions.
Right. You could replicate a clone from a snapshot as well.
Yeah.
So there are a lot of interesting possibilities.
Yeah. A lot of interesting possibilities. And especially if you tied into like Kubernetes, it can make sure that all your network connectivity comes back up and everything's connected. So now I can have a mesh of these snapshots of containers that I'm just firing up left and right wherever.
Yeah.
And so you've given me stateful containers.
That's right.
That's now I'm going a little bit crazy in my head. Because this to me is a huge game.
Yeah, so I think we are into some big games for sure. I think including the CXL revolution that are happening.
Yeah, and you put CXL underneath,
and then you have the snapshot service on the cloud that can give you the encapsulation of the applications and allow you to go anywhere. I think it's going to be a very powerful combination, and there are a lot of exciting things that's going to happen.
You know what, Charles, it kind of reminds me of Max Headroom from the 1980s, that TV show Max Headroom.
That's a little before my time.
That's before your time. Oh, great. I'm aging myself. All you older guys like me, go out there and watch Max Headroom in the 90s and 80s, and you'll know what I mean. Where things are completely mobile across multiple clouds in the data center. Pretty impressive. Charles,
I'll look it up.
Go look it up. Well, in fact, we'll have a picture on the blog of the Max Headroom guy up front. That'll be cool.
Yeah.
Charles, this has been, every time I talk to you, I get blown away with the things that you guys are doing. I'm glad to see you guys are getting awards. You deserve them. You guys are really on the cutting edge of some of the latest and greatest technologies.
Thank you. And it's been a pleasure talking on this show every time. And Intel has been a tremendous partner for us, from Optane to CXL, now onto everything else we do as well.
Yeah, I really see a bright future for computing, and one that my kids won't even recognize. I have now 3 kids that have graduated in technology and are now working in the industry. And I'm envious of them for the things that they're going to see.
Yeah.
Because it's gonna be very different from what we grew up with, for sure.
Yeah. My daughter is just graduating this year in another month.
Another month? What's she graduating in?
CS, actually.
And CS, computer science, yeah. That's my kids. I have a electrical engineer, a computer science, and an IT a graduate.
Yeah.
So
I only got 2, and my first one is CS. Second one will not be in technology, and it's good to have someone different.
Yeah, hopefully a lawyer or a doctor. You need to keep one of those in the family, right?
We'll see.
All right, Charles. Again, hey, thanks. This has been wonderful.
Thank you, Darren.
Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and do something wonderful.